Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the motions of particles. In the last lessons, we have looked at some of the other applications of calculus, like bounded curves and volumes of revolution. Today, we will study the work done by a variable force. If you are ready, let us get started. As we have learned already, if a particle is displaced from one point to another, there is a force at work. Let us call the force F. We will say the particle moved from coordinate x1 to coordinate x2. In that case, the work done by the force is expressed this way. Make a note of this, please. We will use this formula to solve a problem. Let us find the work done when a particle is moved through a displacement of 10 meters. We will define the force like this and say that the motion is across a smooth horizontal surface. In that case, our calculation should look like this. Integration gives us the difference of 90 and 100 over 4. The work being done by the force is equal to 65. Do you understand the new ideas we are discussing, students? If you feel that you do not quite understand something about particles in motion, do not be afraid to ask teacher for help after the lesson. We will now discuss the motion of a particle in a straight line. Let us say that the particle is moving from 0 to x. 0 is the starting point. The velocity is the rate of change of displacement with respect to time. The acceleration is the rate of change of velocity with respect to time. The equation to find out the velocity of the particle looks like this. If we want to find out the acceleration of the particle, it looks like this. Note that we have to find the velocity first. Now, let us consider a different particle. This particle is moving away from 0 in a straight line. It has an acceleration of 3.5 t. When t represents 2 seconds, then P has a velocity of 15 meters a second. But if T were to represent 5 seconds instead of 2, the situation changes. Can you tell me what the velocity is? Please try to answer this question now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I hope you did well with this question. Let us examine the answer together. When we integrate our variables, we are left with the solution of v equaling 7 of 4t squared plus 8. Does that resemble your answer? If it does, great job. Once we have calculated that, we can equate t with 5 for our final answer. The velocity with t equal to 5 is 51.75 meters per second. Take a moment to study this answer. It is a good working model of how to calculate for particles in motion. We will try another example. Using the same equations, I would like you to answer this question. This time, the particle is starting from point A with a velocity of 4 meters per second. It is moving along a straight line called AB. It is accelerating at minus 1.5 t squared at a time of t seconds. Please try to find the particle's acceleration and its displacement after 10 seconds. I am confident that you can answer this question, students. Please get started.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Calculating the acceleration of the particle is not too difficult. If we define t as being equal to 10, it means that a is equal to minus 1.5 times 10. In other words, a is minus 150 meters per second squared. Finding the value of s is a bit more difficult. So, we are lucky we have formulas to help us. V of t at 10 seconds is given by the integral from 0 up to 10 of a of t dt, and v of t is negative 1 over 2t cubed. Finally, the distance traveled at t equal to 10 seconds is evaluated as the integral from 0 up to 10 of v of t. This is equal to 1,250. If that was your answer, you are showing real aptitude for determining the movements of particles in motion. Great work! That is all for this lesson, students. In this unit, we have been introduced to integral calculus. We have learned that integration is the process of finding a function when the function's derivative is known. We have even learned how to solve some real-life problems using what we have learned in this unit. You have all done very well. I am looking forward to seeing you all in the next unit. Until then, thank you, teacher. Thank you, students.